Hi, let's learn how to test optocouplers. An optocoupler or opto-isolator is an optical electronic component with a very high insulation between its input and outputs. We can find them with just one LED or even with two LEDs, one in opposite direction to the other. We can find them with BJT transistors in a Darlington configuration of them, just one output, transistors arrays, UJT transistors, MOSFET transistors, triacs, silicon control rectifier. Some of them they have, as example, this one, zero crossing circuit. Is a very sophisticated system that will detect the magnitude of the voltage over 0 or under 0 volts. Also, we have examples like this one with a logic device and the mixing of logic and analog devices. This one has a transistor too. Now, let's go to learn how to test them. We have a lot of things to solve on the way. The first one is, what are we dealing with? We know maybe we have two LEDs or one LED in the input and we don't know what is in the output. So to fix that problem, the first thing we have to do is to write down the number, go to Google and get the data sheet. Then we know what are we dealing with and we will know what to expect from it and how to test it. The second thing is how to test it. Okay. The first main idea I can get is I should use the multimeter in diode test. Okay. Now, maybe I can use two multimeters, put one in the LED and the other one in the output. And supposedly, in the good theory, if it is okay, this multimeter will light the LED and this other multimeter will give me something in the screen. The first problem I found out is it's so uncomfortable to do it like that. And the truth is, it has no sense. There is no room for it. And maybe I cannot get it with two multimeters. So let's go for plan B. For the plan B, I got only one multimeter with the diode test. And to make it easier, I got some connectors from a bunch of wires I got around from an old TV or I don't know what was it, and I will use them to keep the contacts with the chip's leads. They are easy to place and easy to get measurements from it. So now I got the tools I needed. I will also use an external power supply with 5 volts, 4.5 or 3.3 volts. If you don't have an expensive power supply like this, maybe you can find around an old charger for a smartphone or mobile phone with 5 volts or even the old Nokia's 3.3 volts. They will be good for us. So don't spend too much money on it if you don't need it. Save money because anyhow you have to buy a lot of equipment and to invest a lot in your workshop if you want to prosper. So be smart, and in the beginning use your brain and later use your money. This is the plan. I know I have to light the LED. This test sometimes works for the chip on the board. Sometimes it doesn't. If it doesn't, we have to remove the chip out of the printed circuit board, and we will probably need a board like this to test them. If you don't have a board like that to test them, then you can go for something like this other one until you can invest in something alike. This is the plan. I know I have to light a LED, and in most switching power supplies, the optocoupler is linked to the 5 volts output. Why? Because the other voltage can be used for analog functions, but the 5 volts is the one who requires more precision. By the way, most TTL systems after 5.25 volts, they are in danger. So I know from the 5 volts output comes to this place, to the LED, and whatever is made from here to that place is already engineering design to resist and support the 5 volts feeding on it. That's the reason why I said I'm going to use 5 volts. I strongly recommend, if you can use 4.5, in my opinion the best. Even 3.3 will work. If it doesn't work, we have to remove it and use the external board to make a test. Also, a power supply like this with 2 amperes is too strong. I can give a lot of current and make a lot of damage. So I'm going to set up a limitation for it. I'm going to use, it could be 1 kilo ohm resistor or 2.2 kilo ohms resistor in serial with the output from the power supply and to the LED. In that way, I will not expose to make any damage in that area, and I can make a test on board. As I said, if it doesn't work there, probably we have to remove the chip to make a test in another place. There is here the serial resistor and the power supply in 4.5 volts. Before to do anything else, as I said, let's look for the datasheet and let's find out what are we dealing with. Now we know there is a diode, LED diode in one side and a phototransistor in the other. One is the collector and the other one lead is the emitter. So let's put our test lead here in the output and let's put voltage to it. Do you see the voltmeter? I will remove the voltage. I will put it again. There is conduction, there is not, and there is a gain. Guys, we have a little onboard test for optocouplers. Let's go for the other one. There is conduction, there is not, there is, okay. We know the second guy is good too. I will not go for the third one because it's very uncomfortable for us. There is here another optocoupler. Let's check the datasheet. It says in one side there is a LED diode, in the other side there is a silicon controlled rectifier. Now that we know what are we dealing with, let's try to make the test. There is conduction, there is not. There is conduction, there is not. As I said, this kind of test will work for a lot of onboard optocouplers, not for all of them. Some of them you will have to remove them and test them out. And probably if they are bad, you will have to remove them anyway, and just to certify outside of the board that it was bad. Don't ever think optocouplers are small devices. Solid state relays, they're optocouplers too. And we can test them in the same way we just learned on this video. To fix requires technical knowledge. To be practical is an art, but any art means a lot of practice, self-discipline. This is electronics. We don't work, we just enjoy with it. Thanks by watching it.